Hi everyone. This is another look at intermolecular forces and how we can use them to rank the order of melting points amongst different molecules. I have four molecules up here: water, methane, C3H8 is propane, and CH3Br, it's bromomethane. I've already shown the structural diagrams and I have the different intermolecular forces listed. Let's go through them one at a time. How about water? Does it have London dispersion force? Yes. Every molecule has London dispersion force. How about water? Is it a polar molecule? It has a V shape. V shape is automatically polar, or when I look at it, the top and bottom are the same, but the left and right are not. It's asymmetrical, it is polar, it does have dipole-dipole interactions. How about hydrogen bonds? Does it have hydrogen attached to nitrogen or oxygen or fluorine? Yes. Clearly the hydrogens are attached to the oxygen here, so a third time, yes. Moving on. Methane. Does it have LDF, London dispersion force? Yes. Every molecule has it. Is this a polar molecule? We've seen it a few times already. It is symmetrical. The top and bottom are the same. The left and right are the same. It is symmetrical. It's non-polar. It does not have dipole-dipole interactions. How about hydrogen bonds? Does it have hydrogen attached to nitrogen or oxygen or fluorine? Well, it doesn't even have nitrogen, oxygen, or fluorine in it, so no. How about propane? Does it have London dispersion force? Yes. Everything has it. How about dipole-dipole? Is it symmetrical? Is it polar? Here it's big, but the top and bottom are the same. The left and right are the same. It is symmetrical. It's non-polar. It doesn't have dipole-dipole interactions. How about hydrogen bonds? It doesn't even have nitrogen. Doesn't have oxygen. Doesn't have fluorine. No. Finally, CH3Br. Does it have LDF? It's repetitive. Every time, yes. How about this one? Is it polar or not? Here, the top and bottom are the same, but the left and right are not. It has hydrogen on the left, but bromine on the right. It's asymmetrical. It's polar. Does it have hydrogen bonds? Does it have hydrogen bonded to nitrogen, oxygen, fluorine? Well, it doesn't even have nitrogen, oxygen, or fluorine, so again, no. Now, after we've analyzed all of that, we're going to put these in order. We're going to rank them from lowest to highest. The lowest are going to be the ones with the least check marks, and then we're going to go up and up and up. This one has one check mark, 3. Oh, we have a tie for lowest. But in a tie, the larger molecule is going to have the higher melting point or the higher boiling point. So out of these two, they're both low, but CH4 is smaller. It has a lower molar mass. It has a lower total number of electrons. So we're going to give it a 1. It is the lowest of them all. It has the least number of check marks, and in the tie, it's the smaller one. Now this one is next. It has 1 check mark, but it beat out the methane because it was larger. 2. To decide between the other two, the water has 3 check marks, but this one over here, the bromomethane, has 2 check marks. We started with 1 check mark, 1, 2, and so this one is 3. And the one with the higher boiling point, the highest of them all, over here is the water with 4. When we're asked to rank molecules based on melting point or boiling point, what we're going to do first is go through all of the molecules to think about the intermolecular forces. Once you do that, you're going to look from smallest check marks to biggest. In the case of a tie, the larger molecule by molar mass or the larger molecule by total number of electrons is going to get the higher number. Here these both had 1 check mark, but methane was smaller, so it was the very lowest. Then 1 check mark, but bigger than the methane, 2. 2 check marks over here was our third one, and the one with the most check marks was the highest. We need to take our time. It's kind of a big question to work through, but we can do it. and I hope this helps.